Ladies and gentlemen, how are you? My name is Craig Otto. I'm a Lean Six Sigma Master Black Belt, and today we are picking up in our Yellow Belt training series. Today we're going to do a follow-up video to video 3 of training. So this actually represents the 6th video of this series. I do training videos first, followed by hands-on application. In our case, we'll be doing hands-on application with a Lego simulation. And so this particular effort is about one-piece flow. This particular simulation is. And just a reminder, you can get more of this information on my YouTube channel, as well as www.ottopx.com. So with that, we'll go ahead and get started. As mentioned, this is the 6th video. This is a follow-up to the 5th video, which is called the video 3 on one-piece flow. We're going to use a Lego truck simulation to represent how we're going to implement one-piece flow. Just as a reminder, we document and track all of these different metrics to see how each of the different tools impact the overall business performance. And you can see some of the information there so far. Last time we implemented 6S and definitely helped with our profitability and things like that. And hopefully this one-piece flow will do the same. And of course, we document everything with our A3 process. Today, we're going to be talking about our rapid experiments. Last time we did 6S. This time we're doing one-piece flow. So we'll make sure we get that information documented in our A3 so that it is able to be shared and learned in other value streams and applications. All right, so as mentioned, we are going to look at one-piece flow. Again, this is a principle. It's probably one of the most difficult principles for a lot of production operations because it does limit some of your flexibility. It forces you to do the right thing, forces you to fix the problems. So the goal is to build one and then flow one to takt time. You'll see that takt time is your available time over your customer divided by your customer demand. So it's basically the beat of the customer. How often do they need the product or service that you're providing? And that rate is what you want to build each of the products at in a one-piece flow type of manner. And just to kind of demonstrate that, again, this will show you a quick demonstration of takt time and how each of the different operations move through the process. The material, tooling, fixtures, equipment, you can see from the legend down in the bottom left. This is one of the benefits of one-piece flow. You don't need every station to have everything. And so you can minimize the cost and the maintenance cost of some of these things. So let's go ahead and watch. Here you can see takt time has started. Each of the stations, they move one and they do their work, and then that process is then repeated over and over to that takt time. And the reason that this is something that is a principle is because when the work is standardized or consistently repeatable, it does provide the best way of doing something efficiently. The benefits are that it is predictable. In other words, you get the product on time. It is very consistent in terms of quality, so you get a better quality product. And it's overall more cost-effective and efficient because you're able to address some of the issues that happen in your process immediately. One of the phrases is you stop production, so production never has to stop. And I already talked about how it requires less tools, less conveyances, equipment, fixtures, materials, all that good stuff. The only time that the principle would not work very well is when the work is non-standard. And those types of stations you may want to do bay style, which I talked about in video training number 3, which was video 5. All right, so now we're going to go ahead and take a look at our one-piece flow trial. You can see here each of the different operations are building one at a time and then passing on. Last time we were here, we built in batches of 5 before each of the things were moved on, so we had to wait. And so the first 2 bullets there we addressed was 6S. You can see some of the other items. Station 1 still takes a long time, and honestly, stations 2 and 4, station 1 takes less time, and stations 2 and 4 take a lot more time. But one of the things that we can see is that with the less parts, right, we're able to move the parts to the next station a lot quicker because we're not waiting on the 5 parts. We're just making one and moving one. We're not talking about takt time yet in this trial. The reason is that's going to be a different tool. We're going to use that with standard work. But for the purposes of this trial, we can see it in the metrics of how this would benefit. So we did capture the value stream analysis metrics For trial 3, I put all the data in there. We can visually see it a little better here on the next slide. So here, I like this slide because it shows kind of the current state, which is the first bar in each of the different graphs. The next bar represents 6S, so you can see how 6S impacted the metric that it's showing. And then now the third bar, which is the trial we just did, represents the impact to that one-piece flow. So you can see quality, no issues with one-piece flow compared to the previous 2 times. We did have some quality issues. The whip did not get better. In fact, it got a little bit worse. There's a tool next time we're going to use called Pull Systems that should hopefully help address that whip. The space, less space, so that's good. The amount that we shipped out was much better for one-piece flow. So you can see that is up above our goal, actually. Going down to the bottom left with efficiency, you see one-piece flow was more efficient. The lead time, because the whip didn't change, you can see lead time didn't change much. The batch processing, you can see we went from 5 units down to 1, which is good. And then, of course, by doing that, you can see the profitability of our business as also, at least we're in the black now. Before we were losing money, and now we are making money. And that's what it's all about. All right, so again, we always want to fill out our A3. So this time we're going to add to our 6S. We're adding in there that we did one-piece flow. So that's good. We'll keep building on this as we do the project. All right, so just a quick summary of the one-piece flow effort that we did. When we implemented this, we saw that one-piece flow helps reduce the space required within the cell because you don't have 5 parts built up and waiting for everything to get moved. So that's good. We saw that it created more consistent and timely flow for each station. We saw that it created more output in a timely manner because we produced more vehicles. And also the amount of equipment and tools, materials, fixtures, templates, conveyances, all reduces because of one-piece flow. So that's a lot of cost reduction. And then, of course, the quality improves because you have that real-time feedback. When you find an issue, you know right where to go in the process to get it fixed. You can airproof, and the process just gets better and better. And the other ways, a lot of times you'll have suspect parts kind of all throughout because some people do it right, some people don't, and it's very difficult to figure out what the issue is. All right, so that was pretty simple. One-piece flow, we can see that it was very beneficial for many reasons. Hopefully, we'll be able to tie this in the next few, because one-piece flow alone, while it's powerful, it's even more powerful with pull systems and standard work. So we'll get into using those tools in the next several videos, and then you'll see how all of these, the reason I call these the core tools is because when you implement them one by one, yes, they work, but when you implement them together, they're super powerful. They get incredible results, drive tremendous business results and improvement. And so hopefully you're starting to see that as we go through each of the trials and kind of build on each of the tools and learn. That will be all for today. Again, please like and subscribe to my channel. It's very important to get the information out there. And the more people like it, that will drive more people to see and learn. And that's what it's all about, is continuous learning. And thanks for joining me. Don't be afraid to check out OttoOpX.com for even more information on other types of training with continuous improvement and operational excellence. We'll see you next time.